All right, we are going to start off with complex numbers. So if I square root, -1, I get the number I. I is an imaginary number. Imaginary numbers and real numbers don't mix, kind of like oil and water. So if I had a real number, 6, and I added an imaginary number, 3i, that is as simple as it gets. And together, so this is the real portion, this is the imaginary portion. Together we call them a complex number. Now, technically, 6 is a complex number. It's like 6 plus 0i. And I is a complex number because it's like 0 plus I. So we sort of use imaginary and complex numbers interchangeably, but technically they're all complex numbers. All real numbers are complex numbers. All imaginary numbers are complex numbers. So here, we need to distribute the -3i, and we multiply real portion and imaginary portion and imaginary portion. So the first one would be 15i, and then minus 12i squared. What is I squared? Well, I is equal to the square root of -1. So I squared would be the square root of -1 squared, which is -1. -1. What would I to the third be? Well, I to the third is just going to be I times I squared. So what happens when I multiply those together? I get -I. What about I to the fourth? I to the fourth is just I squared times I squared, which would be 1. What about I to the fifth? So that would be I squared times I to the third, or I to the fourth times I. There are lots of ways to do it, but no matter how you multiply them together, you get I. What about I to the sixth? That would be I to the fifth times I to the first, which is I times I, which is I squared, which is -1. Do you see a pattern? What is I to the seventh? -I, and I to the eighth is going to be 1. So we just sort of have this block that repeats itself over and over and over. Okay? What is I to the 7,643? I don't know. How are you figuring this out? If it's odd, it's got to be an I. Which one is it? Is it I or -I? So we just need to divide this by 4. If I take 7,643 and I divide it by 4, what does the 1910 mean? What does 1,910 tell us? So we divided that number by 4. That would be the number of times we run through the list. So we run through this list 1 time, 2 times, 3 times, 4 times. We run through the list 1,910 times. Do we care? No. What does the 0.75 tell us? It's the third one. Why? It's 3/4 of the list. So we run through the list 1,910 and 3/4, which would be, is that what you guessed? You guessed right? Okay. So what if I did I to the, well, let's just make up a really big number. and we divide it by 4. Oh, that's too big for the, sorry. What about that one? It's 1. How come? We finished the whole list 3 million something something and 78 times. So that would be the last one on the list, which is 1. So what if I did 65 divided by 4? That would be I. So we did the entire list 16 times, and then we did 1/4 of the list, which would be the first entry. Okay, so what is I squared? -1. So I replace this with -1, multiply it by -12, and I get 12 plus 15I. You all right? Just trying to stay awake? Late night? Fortnite? No. Didn't. Oh, I'm sorry. That stinks. You might as well do something productive if you can't sleep, right? It's the worst when you're half asleep all night, not awake enough to do anything. Okay. Here we just combine like terms. We add real portions and imaginary portions. So 3 minus 5 is -2, and -5 plus 2 is -3i. Easy enough. Have your Chromebook started working? No? Simplify this as much as possible. Uh-oh, he's on his phone. Are they good looking? Oh, you have to go tell your mom why you have a citizenship deduction now. So here, we just simplify the roots like we would normally, and then the negative becomes an I. So in this case, does the square root of 5 simplify? No. So this would just be I root 5. But what if it was the square root of -24? Does 24 have any perfect squares inside it? Which one? 4. So we square root the 4, and we get 2, and then what's left? The 6, but I need to move the negative to an I. Where does the I go? Between the number and the square root. If you stuck it over here, it's hard to tell if it's inside or outside. So we always put the i's in front of the square roots. If there are variables, then we would do numbers, variables, I, then the square root. Well, that wouldn't work, but so that's where we always put them, right in front of the square root. Okay, this is simplifying the powers of I. So 45 divided by 4. And remember the list was I, -1, -I, and 1. So in this case, it would be I, because it's 1/4 of that list. Okay. So we simplify this. So 160 would be 10 and 16, 5 and 2. 16 is going to be 2, 2, 2, and 2. So we circle any pairs. So what goes on the outside? 4i. What stays on the inside? 10. And then this is just a 5 and a 2. So what do I bring out? Just the I. Root 10s cancel, and the i's cancel, and the answer is 4. Okay, what if it simplified to be 6 over 10 I root, let's say 10 over root 15? What can I simplify here? A 2. So we get 3 over 5. The I does not simplify. What can I simplify there? A 5. So root 2 over root 3. Can I cancel the 3's? No, it's not actually a 3, right? This is the square root of 3, and this is actually 3. So nothing on the outside can cancel anything on the inside. Okay? So here we have negative 3 times 15 is negative 45. We break that down. So we circle a set of 3's. 3i root 5. What if the 15 was negative? What would that do? We turn this positive, and now there's no I. Okay. So it wants you to use the ALEKS graphing calculator to find the real zeros of the quadratic function. So I'm going to push the graphing calculator. Well, I'm going to have to go from my desk. So I go into y equals, and I type in 4x squared, maybe, squared, and then there we go. 4x squared minus 6x minus 2. Then I push graph. Okay. Now, it does not hit at nice numbers. So how do I find those? Well, I click on 0, and it says, where do you want me to look? I want to look between negative 1 and 0. And there's the answer there. Okay. For the next one, I want to look between, so it looks like it's about 1.8. So I want to look between 1 and 2. And it's 1.78. Okay. If the graph misses the x-axis, then you just write there are none. Okay. Dividing complex numbers. So one of the rules for simplifications is don't leave square roots and don't leave i's in the denominator. So to fix this, we need to remove the i's from the denominator. The way we do that is we times it by its complex conjugate. So every complex number has like an evil twin. It's almost the same, except it's negative. So the conjugate for this one is going to be 4 plus 5i. But I can't just multiply one piece of the equation without ruining the other piece. So I have to times the top by 4 plus 5i. Now 4 plus 5i divided by itself is just 1. So by multiplying this expression by 1, I'm not changing anything other than what it looks like. It's the same person, it's just in a different outfit. So the denominator, some cool things happen. We get 16 plus 20i minus 20i minus 25i squared. These will always cancel. That's why we chose complex conjugates. So the middle term cancels. Also, what is negative 25i squared really? It's just 25. So 25 plus 16 is 41. That is my denominator. The top is going to be a little bit more complicated. I get negative 12 minus 15i plus 20i plus 25i squared. Well, 25i squared is really just negative 25. Negative 12 and negative 25 make negative 37. And negative 15i and positive 20i make plus 5i. And we double check. Do these have anything in common? No. So that is considered a simplified complex number. So I had i's in 2 places, and now I only have an I in 1 place. Do you want to see another one of those? Okay. Hey, oh, it's writing it separately. So I had negative 37 plus 5i over 41. You can split it into its own pieces. It might make you do it that way. I'm not sure. I multiply the bottom by its conjugate, 3 minus 5i, and the top 3 minus 5i. The top is going to give me negative 6 plus 10i plus 9i minus 15i squared. And the bottom is going to give me 9. And then this one and this one are going to cancel every single time. So I'm going to skip them. If you write them down, all you're going to do is cross them off. And then multiply those. So minus 25i squared, which is really just plus 25. And this is really just plus 15. So negative 6 and 15 make 9. 10i and 9i make 19i. And that's going to be over 34. So it probably wants the answer as 9 over 34 plus 19i over 34. And you can either put the I on top or you can put it out on the side. It means the same thing. Whether it's on top, just don't put it on bottom. That would mess it up. Okay. We did the negative b over 2a thing already, right? Okay, so this is just a review of that, but this one might have solutions that aren't very nice. So negative b over 2a is going to be negative 12 over 2, which is negative 6. So my vertex is negative 6 something. So I plug in negative 6. So negative 6 squared plus 12 times negative 6 plus 32 is negative 4. So my vertex is negative 6, negative 4. And how does this parabola open? Normally, so it would be over 1 up 1, over 1 up 1, over 2 up 4, over 2 up 4, and look at that. We know the roots. So you'd graph that parabola. The solutions are negative 4 and negative 8. All right. That's it. Get to work if your Chromebooks are working.